Hello and welcome back to Let's Code Physics. I wanted to first update you today on a couple of neat things that I've discovered and added. The first is I've learned that in VPython you can press the Alt key to pause your animation, which is pretty cool. I'm going to have to mention that in my class later today, and then you press Alt to unpause it. Unfortunately, when you right click to rotate around, it resumes the animation, so you can't. I haven't figured out yet how to rotate a zoomed animation or a paused animation. I'm even trying Alt right click now. But anyway, I thought that was pretty neat. I'll be using that later today. The other thing that I did off camera was to add some display information for us, because we are going to be testing out different launching scenarios, and we'll be interested in the results. So this is displaying the current launch angle and launch speed of the current trajectory. Now obviously the angle and speed of the projectile change as it moves around. We could have it update with that if we wanted to, and then our pause feature would be rather handy. But for right now we're just interested in the initial conditions, because that's what we're interested in testing, is what different initial conditions produce the results that we're interested in. Speaking of what we're interested in, let's take a look at today's code regarding making a field goal in American football. Before we get to that, up here is the code I used to create those text labels. So this command label basically creates a text box with a given position, a given text, and then there's some graphical information here, whether you want it to be bordered by a box, whether you want that box to be opaque, and then basically below in the loop you just modify this angle label dot text value and the speed label dot text value to represent the value that you're currently using. Pretty straightforward stuff. So let's go down to see what we're setting up today. We are setting up trying to make a field goal, actually in this case an extra point in football, which an extra point is just a field goal at a certain time from a certain distance. I believe the rules are the same. I think you still get the same, like, holding of the ball and everything. I don't think there's a different formation. I don't know. Football and physics buffs, comment. Let me know what are the subtle differences between field goals and extra points that I'm missing besides the distance. So in American football, the goalpost makes this sort of blockish Y shape. Actually, let me go ahead and show you in the animation. We've got it all the way over there, so our current projectiles are not reaching it. So you've got this Y shape. Actually, it's more like a tuning fork. So you've got what I'm tentatively calling the bottom bar. You've got the crossbar, and then you've got the two goalposts on the left and right side. So we've got four boxes that we've got to create, four blocks. And so I've just recycled the wall stuff that we worked with last time, because if it ain't broke, don't fix it. You never write new code. So the height of the bottom bar is converting into meters, 3.048. The thickness doesn't matter all that much, because we're just trying to see whether the projectile makes it within this rectangle right here. So if it doesn't make it into that rectangle, it doesn't matter whether it bounces off the bar or whether it sails right past. The important thing is whether it makes it into this rectangle, and that's where our rotational view is going to be pretty handy there. And then the distance to the kicker for an extra point, which of course is your attempt to kick it into that rectangle after scoring a touchdown, has a distance of 30.1752 meters. That's at the 33-yard line, or 33, is it 33-yard line or 33 yards distance? Well, either way, I converted the total, and it's going to be this much. And then we have the bottom of that wall needs to be set to the ground, so that the bottom bar needs to be at the ground. And then we create the bottom bar here in our usual command here. And then we need to do the same thing with the crossbar. So the crossbar needs to start up at the height of the bottom bar, so that's where wall Y is coming from. Its width is just over 5.5 meters. And again, we'll give it a thickness of 0.1 just so everything looks consistent. And then we need the two goalposts. So one of those is going to be to the left, one of those is going to be to the right. So when we calculate its X position, its Z position, because we're going in and out of the screen with those, we're going to give that a wall Z in one of them and a negative wall Z in the other one. So that way they're on either side of 0, equally distant. And then we've already observed in the animation that our current settings are not going to cut it. This is not a very successful extra point. This is barely making it past your own team at that point. And if we look at it, we can see that a typical kicking speed is about 50 to 60 miles per hour. So that's between 22 and 27 meters per second. And we are currently launching with a speed of 4 meters per second. So this thing needs to increase by more than a factor of 5. So what I'd like to do is to try some different speeds and get an idea of how wide of a window you can have the launch angle be and still have a successful extra point. So for example, let's try about the average speed. So we're going between 22 to 27. So let's try 20. Let's see, that would be 24 and a half, I suppose. Yeah, let's try like 24 and a half as a nice average between the two, 24 and a half. And then excuse me. Our typical launch angle is between 22 and 45 degrees. 25 and 45 degrees. Let's expand that just a little bit to have, let's start it at 20 and let's go all the way to 50. Just in case there's something that these kickers are missing in that range. But also make sure we cover, all the values that we want to. And let's actually make the delta angle a little bit smaller. Since we've got a smaller window, we can have delta angle be a little bit smaller. Cool, so we've got our projectile speed. We'll have our angles looping over, so let's run this and see what we get. Alright, and we're launching, and I thought this thing auto-zoomed. Oh my, that is... Oh, yeah, they usually go well past it, right? And that's also a shallower launch angle. Let me see. Visual adjustments to this so that we can... Well, I guess all we're really interested in is this part right here. There we go. Now the thing is visible. Okay, so we are launching. These things are launching way past what I care about. Oh, tell you what, let me go off camera for just a second. I'm going to add a wall back here to catch these things, because usually at this point, they would go sailing off into the stands. Okay, I am back. I have added an additional wall at the back of the goalpost so that it can catch our footballs for us. I've also added to the wall stop class an opacity argument so that it's invisible, so that we don't have a wall of green behind the green goalpost. And now our code is running a little bit more efficiently because we're not trailing the behavior of these projectiles after they pass the goalpost. And so far, none of these launch angles are working. So I guess these averages are reported before the rule change, because the extra point used to be closer to the field goal. And I suppose if you move this in 5 yards, these lower two would be making the extra point there. So I guess let's lower our angle range a little bit. Let's see here. So our typical launch angle, I'll just make a note here, that is not working well. So let's lower our initial angle. Let's see, let's start it at, I guess let's cut it in half. Let's start it at 10 degrees. Because this was 20 right here, and it's not making it. And so I guess we need to lower that. I suppose we can, let's stop it at about, let's see, this one all the way up to 50 degrees. Let's stop it at about, let's say 40. Because I don't want to I don't want to close the range up completely because I do want to play around with the speeds a little bit. Okay, cool. So our first few get in there. So let's see, that was, I'm going to need to increase the space between these two, aren't I? So let's see, so we started, I can pause it now. We started at 10, was it? Yeah, we started at 10. Oops. I hit Alt during the Alt tab. There we go. So we've got 10, 15, 20. I bet we could get a little bit lower with that. So let's go all the way back down to 5 degrees. There we go. So 5 does not make it. So we start at 5. Let's see here. Oh, right. And these are going in, I forgot, these are going in increments of 2.5 now. So we're going to start at 5. We're going to go up in increments of 2.5. So we just barely made it up here with 7.5. So I'm going to call that the minimum there. And what I've done is I've started a spreadsheet for us to keep track. Let me zoom this in for y'all. I've started a spreadsheet for us to keep track of the minimum angle and the maximum angle based on the kicking speed. So let's see, our current kicking speed is 24.5. Our minimum angle was 7.5, and our maximum angle to make it is, so let's see here, so this was 7.5, so that adds 1, 2, 3. So let's do 7.5 plus 3 times 2.5. That's the easiest way to do that, right? So we got between 7.5 and 15 degrees. It's just below the goal post. It's just below the rectangle there. So I suppose we could split the difference between those two and add on another, let's see, that would be another half of 2.5. And I suppose this thing could lose another half of 2.5 as well. Oops, that needs to be in calculation with an equal sign. So you've got a 10-degree window in which to work there. Wow, that is some precision work right there. I suppose we could technically go to the other side of 45 and get trajectories that arc up and then pass through. But I don't think that's what you typically do. I'm pretty sure you typically try to launch it up this way. When you kick it up this way, you're going to get a lot more drag. That's usually for the kickoff or a punt or something. I think I could be wrong. If I'm wrong about that, please let me know. We will come back and try some floating kicks going into the goalpost there. Although that might be more fun to save until after we add the drag into there. Okay, let me make a couple of changes to this. We're going to increase the vertical distance between our two text boxes there. And then we're going to start changing our speed. So we tried about the average speed. Let's try going to the bottom end now. Let's try going down to 22. That's below the range that I have here, but for the sake of rounding, let's go down, let's decrease this to 22, and we'll keep our angles the same. So we are now launching more slowly, so those lower angles should stop working, and some of the higher angles should start working now. So let's see what we get here, and I'll zoom out. Alright, so, we still got our lowest one to work there. Okay. Alright, cool. So that gives us an idea of what we have to work with. So our lowest one of 5, is it? Alright, we're starting at 5, going increments of 2.5. So our 5 didn't work. Our 7.5 barely makes it in. So I feel safe recording that as a minimum there. What was our speed here? We made that 22. So we've got 7.5 is our minimum there. Right, yes, so this lower angle doesn't work anymore. We have to go to a higher angle. And so then we've got 1, 2, 3, almost 4. I'm going to go ahead and count that one just for the sake of ease of calculation. So let's have 7.5 plus 1, 2, 3, 4 units going up. So we'll have 7.5 plus 4 units of 2.5. Okay, so we've added that a little bit there. But again, our range is about 10 degrees. So our range here was 10 degrees. Our range here is 10 degrees. So that's interesting. I suppose it might make sense for that to be a constant since we're not deviating too terribly far from a straight line. It's basically the angle that you get from the line here and the line here. Let's keep trying different speeds to see what we get. Let's try our maximum speed. So let's go all the way up to 27 now for our launching speed. It may be that this relationship is nice and linear. All right, let's see here. Okay, so we're seeing stuff like we had with the first one, and of course the first one doesn't make it. The second one does, and we're about halfway there again. So let's repeat what we had before. So we're now at 25? No, that can't be right. 27, excuse me. 27. I cannot keep numbers in my head for longer than about 2 seconds. So let's see. So let's just repeat that first one. So the 6.25, because we're about halfway between the first one and the second one. And then for this one, we need to go from 7.5 up 1, 2, 3, and let's call that one a half again. So we'll say 7.5 plus 3.5 times 2.5. Oh, that does... Oh, excuse me. I should be adding, not multiplying. That would be a square angle. That's not something I have too great of a grasp on. So between 24.5 and 27, our range stays about the same. So it looks like in terms of the angle that you go for, you're a little bit better off sticking toward the higher end of the speed, which makes sense because the parabola tends to flatten out the faster the projectile moves. Okay, so a little bit of housekeeping. Let's sort this. I'm probably getting close to the end of my time for this video, so let's try one more thing. Let's try moving this a little bit closer, because with they recently changed the rule for this. So let's try moving this to the old distance, just to stir up a little bit of football controversy here. Let's see here. So let's see here. Let's see, I've been searching. Yeah, it should be in my recent search history. Let's see, under the new rules, it is 15 yards from the goal line. Let's see, how much is that different? I believe that's 5-yard distance because it used to be 10 yards. So let's check our reference here just to make sure. I think it's a 5-yard difference. Change football strategy, etc., etc. No. I'm. There we go. A few things routine, scoring the extra point at 20 yards. The kick, blah, blah, blah. And now 33 yards, 15 yards from the goal line. Okay. So, let's see here. Additional distance already caused... Okay, so we went from 20 yards to the goal post to 33 yards from the goal post, right? 20 yards out from the goal post, now to 33 yards from the goal post. Okay, so it has changed by 13. So I need 13 yards in meters, please. And that is 11.8872. Oh, no, it's changing by 11.8872. Excuse me. I need the actual distance. So I need 20 yards in meters. So I need 20 yards in meters is 18.288. Okay, so we're going to change this to 18.288. That is significantly different. Yeah, so if you're going from 20 to 33, that's a change by about 50%, and going from 18 to 30 is about a change of 20%. So let's put that into our code here. Let's see. Where is my distance from the kicker? I know I just scrolled right past that. Here we go. And I'll just make a note that it used to be this. Okay. So let's see. Let's see. So I want to go back to the previous version. So this is going to be, let's go back down to 22 for the lower speed. And again, we're interested in the angle of, in the window of angles that makes a successful extra point. So let's go with 22 for our initial speed. Okay, so my lower end is a little bit is not quite as good, but I think I'm getting more in there. Let's see. So we've got 5. This one's going to be 10, and that's about halfway between those. So let's go with, and we're back to 22 now. So let's go with 10 minus half of 2.5. Yeah, that looks about right there. And so then this is 10 plus 1, 2, 3, 4, 5. Let's call that 5.5, just because, well, actually no, that is just barely making it. So we've got 10 here plus 1, 2, 3, 4, 5 units. So we've got 10 plus 5 units of 2.5. Okay, and what I see already, let's calculate the difference here. We'll have the higher one minus the lower one. What I see is these are consistently about 10. This one has a range of 13.75, which is, I mean, 3.5 degrees doesn't seem like much, but remember, that's 3.5 out of 10. That's a 35% reduction kicking window, which is pretty significant. I mean, that means 35% of your kicks are going to... Do I still have the article up? Let's see. 20 yards, only 8 were missed in the entire 2014 season. The additional distance has already caused kickers across the league to miss 13 attempts. So it's gone from 99% success to 95% success. So yeah, that is pretty significant, because you're missing 35% of your, 37.5% of your kicking opportunity. Let's repeat this experiment for 24.5 and 27. So let's go with 24.5 now for our sort of average. All right, let's see what we get. A miss, a hit, not really a hit, but a success. Sorry, in Pathfinder we call that a hit, not a success. Let's see, so we've got 5, 10, so this is going to be 10 minus the lower range, which is what I had here, so let's just copy and paste that. And then for upper range, we've got 10 plus 1, 2, 3, 4. Does that top one make it? Yes, that top one makes it 5. So it's actually the same as it was before. And then let's try 27. Let's go up to our maximum speed in the range. Alright, so about the same. 5, 1, 2, so 10 minus the half a unit, so I'll have the same one there. Let me guess, it's going to be the same thing, isn't it? We've got 10 plus 1, 2, 3, 4, 5 units. It is the same thing. Okay, so we've come to 2 conclusions about this change in the extra point distance. This is not something I was planning on researching until I read it in the article. So what we see is not only has the window decreased, but the window has become more variable, right? So in the old rules, you had a window of almost 14 degrees, and that window was consistent across the kicking speed. So the kicking speed didn't matter all that much. What mattered was getting the angle correct. Now there's a big difference in that the window has decreased, but also that window is now variable depending on your speed. So that is really interesting. So yeah, this has not been a very helpful change for kickers. I mean, certainly making sports more challenging can be a good thing, but this definitely looks frustrating, and I'm not even a kicker. So kickers out there, this is the physics to show why you were frustrated this past season. My condolences. So this has been a lot of fun. We're going to repeat this experiment next video for scoring a goal in soccer, or what's known as football in the rest of the world. And then what we'll do after that is we'll take this into 3 dimensions, because we not only need to think about the angle that it launches at from the ground, we also need to think about the variability of the angle going to the left and right here. So we'll dust off our spherical coordinates and incorporate those in a future video. So thank you so much for watching. I will see you next time. Bye-bye.